Hello, everybody. My name is Sam Stevenson. I have been designing houses for the past 5 years of my life, including structural engineering. And today I'm going to be showing you guys how I'm going to lay out the framing, at least intended, for this particular house right here. Let's get right into it here, folks. What is this house? This is a spec home, and it's two-story. All right, first floor right here, second floor right here. Imagine this shape basically pulled right here to the front of this house. That's what it is. Here's the front elevation. Here's all the, the walls. It's just two floors, go right up, just a regular roof plopped right on top of that. Nothing crazy going on. Here's the back side. Back one floor is just a regular hip roof, and it just blends in with the upper floor as it needs to. We've got some brick stone stuff going on the first floor. That's all we're concerned about there. That's not going to affect our framing. Sometimes brick affects framing, sometimes it does not. We got the right side. Okay, so here's the whole front of the house. Here's the back of the house. Very simple roof here. Very natural. We got this little porch in the front. Nothing crazy there. And then here is our roof plan. We got a few interior details. The only one we really care about is going to be this guy over here, the stair section. This is showing you like, hey, the rise and the run, how the stairwell goes up, and you can see the floor system there. We're going to talk about the floor system today because it's a two-story. We don't have a lot of those very often. But here's our roof plan. So what I'm going to do is I'm going to pull these sheets back up here, and we're going to design on the roof plan. So I'm going to fold this in half, I think, and that gives us this. But what we really need is this, because we're going to start here and go down. So when we're designing framing of a house, what do we think about? Well, we start from the top and we work our way down through the house. So first, we have a roof. Let's take a look at this roof and think to ourselves, all right, can we use 2x6s, 24 inches on center? That would be the default choice we would like to use for almost all cases, at least Texas. And so, oh, there's the screen. We got to make sure it's on the screen. I'd like to use that. How far can I go? I can go 11 feet horizontally in before I need support. How do I know if I have 11 feet in my plan? I use my scale here. Okay, all these are printed out at 1/4 inch equals 1 foot, so I'm going to use that on my scale. And I'm going to check the bottom floor. What do I got? I've got 0 to basically 18 feet. So I'm going to need support down here, and this should be the same. Yep, 18 feet. Now on this upper floor, what are we looking at? What's the average span we're dealing with here? So that's 0 to 10 feet. 0 to 10 feet. Okay, these are even shorter. This is even shorter, and the front porch is even 8 feet. Okay, so I like this. What I'm thinking is I'm going to do one line for mid support for these rafters on the bottom, and then I'll just do, plain wall to hip or valley or whatever. Like no extra purlins needed up here. Cool. I like that. That's simple. So how do our rafters look on a plan like this? Well, if we looked at this upper floor, we would go, ridge down to wall and or ridge to valley. Basically perpendicularly like so. So this is what the rafters would be doing. And once we have these rafters laid out, we can think about what's going on here up on this upper floor. This front porch would clearly just be doing this. Very simple. It's just sloping to the front to the 312. So we don't need extra support in here. So all we have to do is worry about supporting the ridges, hips, and valleys. Okay, which would be here, 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 and here. All right, so those are the places where we're going to need to support. For hips and valleys, we'll do 6 to 8 feet on center, depending on how much weight we got. And for ridges, we try to do that every 4 feet on center as well for purlins, but we don't have any purlins up here. So let's put some braces in. Let's start on like this one side here and move into the house. First, we got this we have this valley right here. So this valley sits down here on the wall, and it comes up at an angle until it hits this little merge point here. Well, anywhere there's a merge point like this, we want to put a brace because we got a bunch of stuff coming together. We want to hold it all up. So that takes care of that. Now, I want to know if this is maybe 8 feet to the corner. It's about 9 feet to the corner. Given the size of the area that's actually loading this, it's very small. So I would be comfortable just not putting any other bracing on this. It's quite appropriate. Now for this one, we can put one right in the middle. That's fine. This one, we have a wall right below it right here. That's this gray dashed line. Okay, and on this side, Also, our pitch is an 812, and so we're gaining a lot of height pretty quickly in this roof, which gives us a lot of room to put our braces in. Now, what does that mean? Let me explain that real quick. Okay, so the rule of bracing is if my roof goes like this, and here's my wall, and I've got another wall inside like this, I can put a brace to that wall at any angle as long as it's not steeper than 45 degrees. Well, like flatter than 45 degrees. Okay, so how do I know how far I can go? Well, I have a pitch of my roof 812, which tells me if I go over 12, I've gone up 8, right? So I can use geometry, horizontal distances, and determine like how far I am. And so the easy way to know is figure out how high you are above the wall, and that's how far out you can reach your brace from the plan view. So braces, in here I have a little bit more weight going on, so what I'd like to do is I'd like to put a brace in here around 8 feet-ish, and I'm going to brace down to this wall that I've got. Actually, hold on. Some of these are dashed, some of these are solid. Which ones? So the dashed ones are the second floor, so I need to pay attention to that. There's no wall there. That's a wall. Okay, so that's taken care of. Now we're going to brace 4 feet on center-ish down this thing, right? And I've got these walls right down the middle. I could brace that super easily. I've got walls here to brace this valley. Now I've got this ridge to deal with, okay? So looking down this floor plan here, that's what I'm looking at. I've got nothing in the bedroom, so I'm going to say right now that I need a beam. So I'm going to put a beam right down the middle of this bedroom, right there. And then I'm going to be bracing down to the beam, no big deal. And I've got walls in here now, so I'm happy once I got my walls, but I'm going to probably need to put a beam in there to support that. Now, the exception would be, I've got a 12-12 here in the front, super steep. If I have enough height, I could actually put a brace in here and brace back to the wall, put a brace in here and brace to the front wall. If I've got enough height, I would rather do that, and then I totally avoid the beam. Everyone's happy. So that's option number 2. So all of our ridges, hips, and valleys are braced up. Our rafters don't need extra support, so we're good to go. What about the front porch? Well, we are spanning from the front edge to the wall, and that's less than the 11 feet up here. So we are actually good to go. We don't need to add any extra support here. All we're going to need is the beams that make the porch, right? When they make the porch, they're going to have to put beams in. Let's talk about the back side of the house, which is actually the first floor. So first of all, where does this house transition, where does this roof transition happen on this plan? It happens right here at this back stairwell wall. That goes straight across, and I'm actually going to dash that out here with a black line. Okay, so this is the second floor. That is all attic space for this part. So first thing we're going to add in here is a purlin line, right? So we got to support our rafters midway down because they can't reach from the wall to the ridge. So what else are we going to do? Well, we got to, I'm not going to draw the rafters in because like they look like rafters. You know what? I will do it. Okay, they're going to go like this on this side. They'll go this direction on this side, and then on this side, they'll go this direction. Okay, there's your rafters. Now, we need to support these purlin lines and these hips and this ridge. That's what we got to hold up. So this is easy because there's a wall right there. And then we got to support that because that's a joint. So now for this one, we're going to try every 6 to 8 feet. In this case, I have a wall really close to here. So I'm going to just put a brace to that. I got a wall right here. So I'm going to split this up into thirds. This is over the garage. Okay, so I'm going to wait to see what beams I have in my ceiling plan and not do anything there yet, I don't think. And then we're going to move down the ridge. This is a ridge, so we're going to try every 4 feet on center approximately, and we've got walls everywhere to use. So the ridge is fine, easy peasy. Let's talk a little bit about the purlins lines. Okay, so we've got basically 4 feet-ish on center. I'm eyeballing it. You would check in real life, of course, but it'd look approximately something like that. And remember, everywhere I put a dot is where we are supporting the purlin, and the line is saying, hey, where's the brace landing? Where's the weight coming down? Is it being put on a wall? Is it being put on a beam? How's that working out? So this one's fairly straightforward. Okay, we could probably, you see that's an 812. Yeah, we could probably reach the wall, okay, with these two. This one, it'd be kind of a stretch, but it looks like it can reach over here. These are floating. These can reach this wall. Potentially, if we go in about 12 feet, we've got 8 feet up. Yeah, so we could actually, these could reach all the way over here and they would not be violating the rule. So good support there. On this side, it's a little bit of a stretch unless we move the whole purlin line. Okay, so how would we do that? We'd look here and we'd say we can go 11 feet. So we can actually go farther. We don't have to put it in the middle. We can put it on the 11-foot side, which gets us closer to the support wall. So I would actually do that. I would say, nope, we're not doing any of this. We're actually going to put this closer to the 11-foot max on this side. That way, when we add these braces in, we can just put the weight on these walls and we're good to go. So that works out just fine. Now let's talk a little bit about our garage because that's the last thing we have not held up here. We got to probably support this hip in 2 places and we have to support these 4 braces on the purlins. So if we'd like to just put 1 beam in, and we also have a big span for the garage ceiling. So it's generally a good idea to just have a big beam over your garage because there's just a lot of open space. So I'm thinking we're just going to run 1 beam and I might just put it right down the middle. This is my thinking. If we put it right down the middle, then this brace can reach it. This brace could go back a little bit to it. It's fine. These can reach it. This obviously reaches it. And then this guy, if we're tall enough, we put it in the right spot, we could reach it as well. So that's how we'd hold up all that. And then we transfer, of course, that beam over to our ceiling plan. So we know there's a beam there. All right. And that pretty much takes care of the roof. All right. Hips, ridges, valleys, purlins, everything's held up. We're good to go. Now let's think a little bit about the ceiling plan on the 2nd floor. Okay. We started up in the roof. The roof is taken care of. Let's talk a little bit about the 2nd floor next. This is what we got. I'm going to actually assume we didn't need this beam because we had enough room to brace. So that beam goes away. This is a very simple thing. All that's going on here is I'm going to pick which direction I want the ceiling joist to go because all these rooms are small. So there's pretty much there's no reason I have a problem here. So if I use regular ceiling joists, 2x6, 24 inches on center, and I use Southern Yellow Pine #2, I can go basically 14 foot horizontal before I need support, which means I can cross a 14-foot room and I'm fine. So this is a 14-foot room. So these ones are fine as well. So I would prefer to cross this the short way. So I'd probably run ceiling joists like this here. So we got a gable end right here. So I'd probably run them with the rafters like that. And then I would basically just pick the short span. I'd probably do this all in one shot. I'm going to use a little 2x6 beam here to cross that hallway. I'd just do these like this. And then if this was like, I don't know, if they were long enough, I'd do more, or I would do a second run, whatever works. Ceilings are pretty straightforward when they're rooms like this. Now, this is a very tiny beam, so we're not going to worry about the accumulated weight on the ends of the beam. But if you are ever doing a 2nd floor or a 3rd floor and you have beams, you must keep track of the ends of the beam and where they come down through the floor system, because those are now concentrated loads. And if you put an 8,000-pound load on nothing but subfloor, it's going to go through the subfloor, or it's going to warp it, or it's going to have problems. You just don't want to do that. So we want to have solid wood on the ends of our beams all the way down to the foundation. That is the goal. Okay. And sometimes that means more beams and more headers, but it also means your structure is very stiff and strong, and all the loads are safely making it to the foundation. In this case, no beams, so we are just not going to worry about it. 1st floor ceiling. All right. Whenever you're doing a 1st floor, but there's a 2nd floor, the first thing you have to think about is where's the stairwell and where is the 2nd floor. Now, I drew this black line here delineating, hey, here's the boundary of that 2nd floor framing. So on the inside of that is our 2nd floor. Therefore, on the inside of that, our beam is going to cross over this room just like that, right? So we have a floor system here, right? And there's weight on these walls from the roof. See all these rafters? They're sitting on the 2nd floor wall. Well, that's sitting right here. So ceiling, normally you want to just do the whole boundary of your second floor with LVL or something nice and strong if you have any doubts, if it's not sitting directly on a wall. Now, in the rest of this case, this whole boundary, all the way around the rest of it, that is actually sitting on the wall, so it's super easy to know. There's a wall piece right there, and there's only two other gaps. There's this gap and this gap. And if it was me, I'd probably just pay them extra money for like, two more LVLs to cross this. I would know it's all strong and happy. And that's what I would go with. So that's the boundary of my second floor, which means the next thing I'm going to think about, the ceiling joists of the part underneath the second floor are floor joists. Okay. What is the difference? Well, normally your ceiling joist is going to be like a simple nominal lumber, like a 2x6, 2x10, something like that. If you have floor joists, you're either probably going to use floor trusses or you're going to use engineered I-joists. We don't usually use a lot of regular lumber for floor joists anymore because it's very inconsistent in width and thickness, and it expands and contracts with moisture content a lot. There's just all kinds of problems. So most of our floor systems these days are engineered material. So an I-joist basically looks like this, and it's some kind of combination of engineered material. Typically, the center of this flange is like an OSB looking product, and this is basically like a really thick plywood looking product. But they can make it out of kind of all kinds of stuff. I've seen this part be like a natural sawn lumber. This is OSB and this is sawn lumber. I've just seen a few different kinds, but that is what we're going to anticipate using here. So the next thing to think about is the stairwell, right? So as you can see here in the stair section, as soon as you start going up the stairs like this is a railing and there is no wall here. The only wall is in the center of the stairway and the back of the stairway. So as you can see, if you're looking at the stair section, this is that center wall that goes all the way up to the roof. And here's that back wall that goes all the way up to the roof. So what that means is there's actually a boundary we need to support here, okay? Now, there's no post drawn in the plan. You could insert a post here and save some money in beams, most likely. But, that's kind of like a little plus or minus here, plus or minus there. It's not going to make a big difference. Posts kind of look cool. I like structural members. But if we wanted to hide it, we would need to support this space right here over to about right here. So we got to support that. Now, we can't build a beam that's L-shaped like this. We have to cross over something. And so we should cross over the shorter span, whichever that happens to be. In this case, if we crossed this way, we're about 18 and a half feet. And this way, if we crossed, we're basically 19 and a half. So it's actually shorter to do the full cross span in this direction. This is also a function of what's your plumbing doing. How's your plumbing going through the ground? Like, you don't want to drill a hole through your beam for plumbing if you don't have to. So like, this is a consideration for the framer and the builder, which way the beam's going, how are we running these I-joists, yada, yada, yada. So in this case, the beam's going to cross here and cross here. And that will make a hole in your floor system for your stairwell. Let's do the floor joist in orange here, guys. Okay, so basically your floor joist, you're going to just pick a span and a spacing and be like, yeah, like this is the deflection I'm okay with for this particular floor system. And then you're just going to basically lay out your whole floor system accordingly based on what you need. And yeah, that's that. You're going to wrap the whole thing in a rim board thing, and that's going to be your floor system. When you select that, usually it is by a chart or a downloadable thing from whoever's manufacturing the I-joists. That's a pretty easy selection to make. But we can also do it in the Forte Web calculating systems if it's complicated. So that's this side. Ceiling on the back side. What's going on? Well, the first thing I want to talk about is here's your garage. And if we're spanning a garage, we got a beam in the center. We want to use that beam, shorten up the span of our ceiling joists, and do this. And I know this end of the beam is okay because I have a lot of room. What I'm going to do to the beam right here, because remember, here's our roof. It's landing on this wall, and so is the beam. So the end of this beam is actually going to look like this. It's going to be nice and tall. It's going to reach the wall, and it's going to have this big angled notch, right? And most of the time, that's okay. The trick is basically, if you've got calculating software and you can prove that this height of the beam does not fail in shear if you design the beam, It's going to fail in bending if it's that small, but if it doesn't fail in shear, then you're fine. Nothing's going to be a problem. So there's all kinds of stuff I've talked about before on this channel about that, but we're here to talk about generic framing. So the other thing I'm seeing here is that, like, all right, let's probably cross this kitchen ceiling area left, right, and we're only going to put one more beam in here, probably from here to here, and that's going to allow us to cross over pretty much this whole space left to right all the way down. Super easy. And then on this side, shoot, I mean, we could 13, yeah, we could just as easily do this over here and then do this in the middle. Okay, there's your ceiling joist on this guy. Your porch, of course, is going to have beams. That's how we make porches. Top of the beam is going to be equal to the top of the height of the wall, and framed outside of framing in line with outside of framing of your wall. So that takes care of the ceiling plan. So folks, we got the roof, top down through the second floor, ceiling, no beams. We just put all this stuff on top of the floor system. We outline the floor boundary, figure out where our joists go, where's the hole in our floor system, and then we look at, hey, here's our attic. Now, one other comment you could make is, hey, look at this floor plan. It's notated this is actually an attic access room. Okay, so they may not build it out of floor system because this is more expensive. They may just do regular ceiling in here. And they also might beef up some of the size of the ceiling joists in this area because they're anticipating weight, right? People store stuff up here. They're going to be bringing weight into the house and storing it on this. So you don't want your ceiling sagging. You don't want stuff breaking. You don't want any of that stuff to go on. So yeah, second floor, first floor, plain basic ceiling, guys. These are not complicated houses. Of course, you would always go through your house and be like, hey, where's all my headers? Because your headers are also structural members where you're displacing loads. So you'd want to track your beams, figure out if your beams are sitting on any headers. In this case, I don't believe we've done that on the first floor. Oh, actually, no, on the second floor, we didn't even do that either. So yeah, in this case, it looks like all of our headers are just regular old simple headers. There's no specially loaded stuff going on here. So I don't know if I got them all, but that's how you would find your headers. Of course, you'd have a big header back here over the garage door. You'd calculate that guy. But that's what I got. We just framed a 2-story house in, 22 minutes, 23 minutes. So now you guys know. Let's do another one next week. I'll see you guys next time, and let's take it out with some music by the one and only Green Observer.
That's the code.